Hello again, friends. It's me, Frédéric, from What's What, and I have a very special guest with me today. Everybody say hello to Kim.
Hello, happy to be here, Frédéric.
We are happy to have you, but be careful around the studio, Kim. Some of these objects can be electrifying. When I said objects around here are electrifying, I didn't think it would be this cable flowers. I guess I caught some static there.
Caught what?
Static electricity. You've never heard of it?
No, what is static electricity?
It is an electric discharge that occurs as a result of an imbalance of electric charges within a given surface or object.
Wait, what's a discharge and an imbalance? I just don't understand.
Don't worry, we will find plenty of ways to experiment with static electricity in the next few minutes.
Yay!
But before we get started, let's ask our viewers to subscribe below.
Don't forget to send a like too.
The use of today. Alright, are you ready for static experiment number 1?
Yeah, maybe not.
Oh, come on! Here, they have 2 of these styrofoam plates and rub them against the clothes. There. Et voilà.
Wow.
Pretty cool. What this shows us is an electric influence between 2 surfaces. These plates repel from one another because they both are giving off positive charges. And charges always resist each other.
Got it.
Now remember, positive charges are drawn to negative charges, and negative charges are drawn to positive charges. Let's try an experiment for real to show attraction. I call it bubble trouble. See this bubble? It moves with a PVC pipe because it wants to create a balance.
Cool.
Here you try.
Can I take this home?
No, sorry. All science material stay in the lab. Okay, take it home. But before we get any further, we have to go over some things that matter.
What's the matter?
No, I'm talking about actual matter.
Oh, okay. Whatever.
The entire Earth and everything within it is built from matter. This is matter, and all matter is made up of atom.
I have a classmate named Adam.
Not atom, atoms. Atoms are these tiny little particles that make up matter. Every tiny atom consists of 3 tinier little molecules: protons, neutrons, and electrons. The electrons are negatively charged, the protons are positively charged, and third, neutrons are, yes, guess it,
Neutral.
and all exist in harmony.
So, what's the problem then?
Usually, there are the same number of electrons and protons in a given atom. But sometimes, things get thrown off balance.
Whoa. Speaking of balance, you better watch your step.
Within every atom, electrons are loosely bound, and because of this, electrons might try to leave their atom. That's when things can get a bit shaky.
Okay, I'm starting to get it, but why do electrons want to leave their atom?
Another great question. Think of an electron as that grumpy kid at school who always strays away from the group on field trips. He wanders off, gets lost, the teacher panics. Next thing you know, the whole trip is ruined.
I've been there before. Oh, those boring field trips.
That is almost how electrons function. Now, once an electron strays away from its atom, or a given object, they look from the next closest object to attach themselves to. In turn, the object left behind will have a deficit of electrons, or a positive charge, and wherever that mischievous stray electron lands, this atom will have a negative charge. Let's try another experiment to put things into perspective. The dancing ball. Drop the balls. Now try touching the glass there.
All these little balls, they move when I press on the glass.
That's right, you touching the material draws away the loose electrons, in turn, throwing those atoms inside the glass of balance. Those little electrons, they are so small and weakly bound within the atom that they will slip away with the slightest disruption. But remember, it's all about the charges with a given object. Here is another one, Wingardium Leviosa. Take a plastic bag, a PVC pipe, a cloth, et voilà. Because of the charges, this bag stays close to the pipe, but not too close.
Whoa, cool. Can I try?
Of course! But one more thing to note, when newly charged objects come into contact with other materials, the mobile electrons move to the place they are most needed, until the charge balance is achieved again. The quick transfer of charges is called a static discharge. In other words, this is how we get zapped. And for our final, the most famous of all the static experiments.
Oh, I know this one.
The oldest trick in the book.
Do you want to try?
No, thank you. Now, to finish things up, I must tell you that static discharges don't just happen anywhere. It really depends on the object at hand and how tight of a hold these objects' atoms have on their electrons.
Like these?
Exactly. Insulating materials such as glass and plastic efficiently prevent their electrons from jumping to other atoms, while conductors such as metals release their bonded electrons fairly easily. And trust me, things can get dangerous when they do. But let's not take electric discharges too seriously. There are many fun ways to explore electricity at all education levels. Do you have any other experiments? Share us with them in the comment section. Until next time.
Bye-bye.
Ouch!